Good evening. I hope you're all doing well. I think tonight we're going to try a recorded lesson, and a lot of people requested that on the survey. So we'll go ahead and give it a shot. If you go to Blackboard under the April 1st assignment, you'll see a document called Video Notes. That's what we'll be using today. If you'd rather, you can just watch on screen where you'll see them. And you might want to have a piece of paper handy to scribble down some details that you might want to remember. In any case, let's go ahead and begin by looking at that document. Today, we're going to be doing the third section, or the third day of what we've started the last two classes, where we've been looking for zeros of polynomials. And in those first two lessons, we learned all the tools. Today, we'll actually be putting them together to actually find the zeros of the polynomial. So we'll start by looking at the polynomial here. F of x equals 4x to the fourth minus 4x cubed plus 3x squared plus 4x minus 4. First thing you want to do is identify how many zeros you have in the polynomial, which is just the degree or the highest power of the polynomial. In this case, that's 4. So since this is a fourth degree polynomial, we're going to have 4 zeros. Next thing we'll do is to use the rational zeros theorem by listing the potential rational zeros. If you recall, rational numbers are quotients of two integers, zeros of the polynomial. The numerator of that quotient are going to be the factors of this constant at the end of the polynomial, 4. And there are 3 factors, 1, 2, and 4. The denominator of the rational zero is going to be the factors of the lead coefficient, which in this case is 1, which has only one factor, and it's 1. So when we look at all the possible numerator-denominator combinations here, we have positive or negative 1 over 1, or 1, positive or negative 2 over 1, or positive negative 2, positive negative 4 over 1, which is positive or negative 4. So now we have our 6 possible rational zeros, which means that this polynomial has a zero, a number that makes it equal to 0. That's a rational number. It's going to be one of these 6 numbers here. So it gives us a place to start looking. Now, you may remember that we mentioned that you're always going to have this positive or negative 1 as potential rational zeros, because 1 is a factor of every number. And we had a quick way to test if 1 was a 0 or if negative 1 was a 0. If 1 was a 0, what we did was we saw if the coefficients added up to 0. In this case, if we looked at the coefficients of this polynomial, which would be 1, negative 4, positive 3, positive 4, negative 4, if it added up to 0. And in fact, it does. That tells us that 1 is going to be one of our 4 zeros. Similarly, we're going to ask if negative 1 is a 0. Negative 1, to tell if negative 1 is a 0, you may recall, what we're going to do are switch the odd powered coefficients. So the 1x to the fourth we'll leave alone. But we've got a minus 4x to the third. We're going to switch that to a positive 4. The plus 3x squared, that's an even power, so the plus 3 stays the same. We have a plus 4x to the first. Now, x to the first is an odd power, so I'm going to switch that plus 4 to a negative 4. And then finally, the constant minus 4, that would be x to the 0. That's an even power, so that stays the same. That's a negative 4. So I'm going to take a positive 1, positive 4, a positive 3, a negative 4, and a negative 4. And they too add up to 0, which tells me that negative 1 is going to be a 0. So by these 2 quick tests, we already know that positive 1 will be a 0, and we know that negative 1 will be a 0. Now, while we're discussing the coefficients of this polynomial, you might recall there is Descartes' rule of signs, whereby we count the sign changes in the coefficients. And that'll help us determine how many positive and negative zeros the polynomial has. In this case, you'll notice that in the polynomial, we have one sign change from 1 to -4, second kind change from -4 to +3, +3 to +4, that's not a sign change. The +4 to -4 is a sign change. So we have three sign changes, 1 to -4, -4 to +3, and +4 to -4. Tells us there could be as many as 3 positive zeros, or remember you count down by 2s, or 1, either 3 or 1 positive zeros for this polynomial. Secondly, for the negative zeros, again, we go look at the coefficients with the odd powers having same signs, like we did here. When we looked at changing the x to the third to a +4, we changed x to the first to a -4. Notice that in this case, there is one sign change from +3 to -4. Tells us there's going to be one -0. So we now know that there's going to be a -0, and there's going to be one positive or 3 positive zeros. And so now we're off and running. Now we can start looking for the zero. And the first one I chose to go after was the easiest one, the +1. So I used +1 here as my pivot element, and I used synthetic substitution. I brought the 1 down, multiplied by 1, and that went in the next column. -4 plus 1 is -3. -3, I multiplied by the 1, gave me -3, that one in the next column. Adding, I got 0. 0 times 1 is 0. Adding 4 to 0, I got 4. 4 times 1 is 4. And finally, -4 plus 4 gave me 0. If you call this 0 at the end, told me that 1 was the 0 of the polynomial. And because 1 is a 0, x minus 1 is a factor. Okay? So by finding the 0 of the polynomial, I now know a factor of the polynomial. And the cofactor comes from our quotient. Okay, so I know that x minus 1 is a factor. That's this factor. And the factor that goes with it comes from our quotient, which would be x to the third minus 3x to the second. You'll notice there's no x to the first. And then we have a +4. So that's x cubed minus 3x squared plus 4. And we've begun by finding 1 0, and now we've started the factoring process. So now I'm working on this polynomial, x cubed minus 3x squared plus 4. You'll notice that this polynomial has the same lead coefficient and the same constant at the end. So my list of possible rational zeros, the 1, 2, and 4 that I started with at the beginning, are still in the game. Okay. Next, if you recall, I've mentioned that -1 was the zero of the polynomial up here. And therefore, I'm going to go after that one next. I'm going to take my x cubed minus 3x squared plus 0x plus 4. Now I'm going to divide or plug in -1 or divide by x minus a -1, plus 1. And when I do that, again, the synthetic division process, the 1 comes down, I multiply, I get a -1. Adding -3 and -1, I get -4. Multiply -4 times -1, I get a +4. Adding 0 and 4, I get 4. Multiply, I get by -1, I get a -4. And adding 4, -4, I get a 0. Remember, I knew that was a 0, so that's what I was expecting. This tells me that -1 is a 0 of the polynomial, and x minus a -1, or x plus 1, is a factor. So now I'm factoring this polynomial, And I factor that, I know that x plus 1 is a factor. And its cofactor, again, comes from the quotient. Quotient here, x squared minus 4x plus 4. Okay, so the product of these two terms will give me the x cubed minus 3x squared plus 4. And now I'm almost finished. Once we get our polynomial down into the product of linear factors, like x minus 1 and x plus 1, and a quadratic factor, x squared minus 4x plus 4, I can start setting things equal to 0. Of course, when I set x minus 1 equal to 0, I get x equals 1. And when I set x plus 1 equal to 0, I get x equals negative 1. Those were the two zeros I found very early in the problem. And when I said x squared minus 4x plus 4 equals 0, well, at that point, it's a quadratic equation. I can always use the quadratic formula. But in this case, it's actually factorable. X squared minus 4x plus 4 factors into x minus 2 times x minus 2. And so I set each of those equal to 0. And when I do that, I get x equals 2 and 2 times, which means that x equals 2 is a 0 of a multiplicity 2. And so now we factor this problem into x minus 1 times x plus 1 times x minus 2 times x minus 2. And the zeros turn out to be x equals 1, x equals negative 1, and x equals 2, which has a multiplicity of 2. Okay. Let's move on to the next one. We'll follow that same series of steps as we go through this process. First, you'll notice, again, number of zeros. The number of zeros, again, is the degree or the highest power of the polynomial. In this case, that is x, that's x to the 4th. So we're going to have 4 zeros. Okay. Next, we look at the potential rational zeros. This gives us our so-called suspect list, the possible numbers that we're going to try to see if they are zeros of the polynomial. Here, my constant is negative 4 at the end. So the factors of 4 would be 1, 2, and 4. Those are the possible numerators of my rational zeros. And my lead coefficient is also 4. So my denominator also could have factor, could be 1, 2, or 4. Moving on, we now look at, again, every possible numerator denominator combination. Well, I'll start with the denominator of 1. 1 over 1 is 1, 2 over 1 is 2, 4 over 1 is 4. Then I go to a denominator of 2. 1 over 2 is a half. 2 over 2 is 1, and we already have that. 4 over 2 is 2, and we already have that. And then we go to a denominator of 4. 1 over 4 is 1/4. 2 over 4 is 1/2, we already have that. And 4 over 4 is 1, we already have that. So it looks like I have 10 possible rational zeros. Positive or negative 1, 2, 4, 1/2, and 1/4. Okay. Next, we look at is positive 1 or negative 1 going to be zeros. Well, notice if I look for 1, again, it just is the sum of the coefficients, 0. Sum of the coefficients here would be 4, negative 1, negative 8, positive 18, and negative 4. You'll notice that when I add those up, I get 9, which is not 0. So that tells me 1 is not going to be a 0 of this polynomial. What about negative 1? For negative 1, again, we switch the signs of the odd power coefficients and ask ourselves, is the sum 0? Well, the odd power coefficient here, I got positive 4, that's x to the 4th, so 4 will stay the same. Negative 1x to the 3rd, so I'm going to switch that negative 1 to a positive 1. Minus 8x squared, even power, so that stays a minus 8. Plus 18x becomes a minus 18, because that's x to the first, and all power. And minus 4 stays a minus 4. That's x to the 0. That's an even power, so that stays the same. So I'm going to add up a positive 4, positive 1, negative 8, negative 18, negative 4. It gives me a negative 25. Again, not 0. So negative 1 is not a 0. Okay? So that's real quick, a little bit of arithmetic. I know that positive 1 and negative 1 now are out of the game. They're not going to be zeros. And now instead of 10, I have only 8 possible numbers to check. So before I start looking through those 8, let's look at Descartes' rule of signs. With Descartes' rule of signs, remember we look at the sign change. In the polynomial, we're looking at these coefficients here. We saw one sign change from 4 to negative 1, and we saw a second sign change from negative 8 to positive 18. We saw a third sign change from positive 18 to negative 4. So that told me I could have as many as 3 positive real zeros. But remember, we could have less. We count down by 2. So I could have 3, or I could have not 2. I could have 3, or I could have 1 positive real zero. But it does tell me something. I know there's going to be at least 1 positive real zero. It could be as many as 3. For as negative real zeros, we go to these coefficients after we switch those out powers. Here you'll notice we have a sign change from 1 to negative 8. And that's the only sign change. So I know I'm going to have 1 negative real zero as well. All right? So I'm going to have a positive, I'm going to have a negative, and I might have as many as 3 positives as we start looking. So with the ones out of the running, the first number I tried here was 2. It's about the simplest number I could try of the remaining suspects here. So I plugged 2 in. Using synthetic division, 4 comes down. I multiplied by 2 and got 8. Negative 1 and 8 gave me 7. I multiplied 7 by 2 and got 14. Negative 8 and 14 gave me 6. Multiplied 6 times 2 and got 12. 18 and 12 gave me 30. Multiplied 30 by 2 and got 60. And negative 4 and 60 gave me 56. Obviously, this is not a 0, so it tells me 2 doesn't work. But now we might recall I talked about upper and lower bounds. Remember that tells me x minus 2 is not a factor. 2 is not a 0 this time. But because these were all positive numbers on the bottom, that tells me that 2 is an upper bound. I don't have to try any numbers bigger than 2. In this case, we only had 1 possible suspect. That was bigger than 2, and that was a 4. So we don't even have to try 4. So now I'm starting to think. I know I've got positive 0. It's not 1. It's not 2. It's not 4. So if it's a rational number, it's got to be one of these fractions. 1/2 or 1/4. So let's try a half. So I plug a half in. When I plug a half in, I'll take the 4 down. 4 times a half is 2. Negative 1 and 2 makes 1. 1 times a half is a half. Negative 8 times a half would be negative 7 and a half. Okay? Now things are going to start getting messy. Negative 7 and a half times a half is negative 3 3/4. Add that to 18, I get 14 1/4. When I multiply that by a half, I get 7 1/8. Negative 4. Needless to say, it doesn't get to 0. So once you start seeing things start spinning off the road here, you can be pretty sure you're not going to get a 0. But follow it through just in case. In this case, it tells me that a half is not a 0. Well, remember again, I know I've got a positive 0, and I've ruled out all the positive possibilities that are rational, except for 1, and that's a 4. So let's try it. When I plug a 4th in, I bring the fourth down. 4 times 1/4 is 1. I add the negative 1 and 1 and I get 0. I multiply 0 times the fourth and get 0. Add negative 8 to 0 and get negative 8. I multiply the negative 8 times 1/4 and I get a negative 8/4, so negative 2. 18 negative 2 gives me 16. I then multiply the 16 times the 1/4 and I get 4. And negative 4 and positive 4 give me 0, and that's what I like to see. I like to see that 0 at the end. It tells me that 1/4 is a 0 of this polynomial, and therefore x minus 1/4 is a factor. So finally, I get a 0, x minus 1/4, and its cofactor is 4x cubed minus 8x plus 16. Again, that comes from the quotient. Okay? So now I'll continue working on this polynomial, 4x cubed minus 8x plus 16. But notice there's no x squared, so I'm going to leave the 0 there. So now I've got my positive 0. I'm going to go towards the negative side because I know there's a negative 0 as well. So with negative 1 out of the running, we mentioned that earlier at the top, I'm going to go to negative 2. So if I plug negative 2 in, I'll have to bring the 4 down, multiply by negative 2, that's a negative 8. Adding 0 and negative 8, I get negative 8. Multiply by negative 2 and I get 16. Negative 8 and 16 give me a positive 8. And 8 and negative, or multiplying 8 by negative 2, gives me negative 16, which I add to 16, and that gives me a 0. Again, that's what I like to see. Excuse me. So that tells me that negative 2 is a 0, and that x plus 2 is a factor. So now I factored this polynomial, 4x cubed minus 8x plus 16, into x plus 2, the factor I just found, times 4x squared minus 8x plus 8, the quotient. Now we're pretty close to being done. You'll notice that this trinomial here has a common factor of 4. So I'm going to take 4 out of each of those, bring that out front, and that'll leave me with x squared minus 2x plus 2. So now I've factored it. That's about as far as I can factor it. So I set each of these equal to 0. Notice that when I set 4 to equal to 0, that's not true, never will be true, so there's no solution. X minus a fourth equals 0 gives me x equals a fourth. I found that up in here. X plus 2 equals 0 gives me x equals negative 2. I found that in here. And when I said x squared minus 2x plus 2 equal to 0, now that doesn't factor, so I did have to use the quadratic formula. And when I did, I got two solutions, x equals 1 plus I, and x equals 1 minus I. So in this case, we knew there was one positive real 0, that was 1/4, and one negative real 0, that's negative 2. And the other two zeros were complex numbers, 1 plus I and 1 minus I. Okay. Now I'm going to pause the tape for a second. We'll go to the other side, which is not completely filled in. If you want to start looking at that, we'll kind of walk through those problems. Okay, back. And let's go back to our here. All right, this one you're going to have to do some filling in on. But here we're looking at the polynomial x cubed plus 8x squared plus 11x minus 20. You notice that the factors of 20, I'm sorry, here we're going to have 3 zeros. Yep, go right there. 3 zeros. The potential rational zeros, we're going to put the factors of 20. There are 6 of them. 1, 2, 4, 5, 10, and 20 over the factors of our lead coefficient, which is 1. That's all. So with the denominator of 1, our potential rational zeros are going to be 1, 2, 4, 5, 10, 20. Okay? We ask ourselves, is positive 1 going to be a 0? Well, if we add up the coefficients, 1 plus 8 plus 11 negative 20, we find that they do equal 0. And so that, yes, 1 turns out to be 0. Okay? How about negative 1? Well, for negative 1 again, we switch the odds powered coefficients. So the 1 will switch to a negative 1. That's an x cubed in our power. The 8 stays positive. The 11 becomes a negative because it's an odd power x to the first. And the 20 stays negative as an even power x to the 0. Notice when we add those up, we end up with a negative 24. Negative 7 minus 4, 11, negative 4, negative 20, negative 24. So that tells me negative 1 is not going to be a 0. Okay? But remember, 1 will be, and we're going to come back to that in a second. Again, looking along the lines of Descartes' rule of signs, I count the sign changes in the coefficients of the polynomial, and we see that there's 1. If we go from a positive 11 to a negative 20 in the coefficients there, that tells me there's 1 positive real 0. I already know what that is. Positive 1, which I saw there. And on the negative side of things, I've got a negative 1. I put positive 8, that's a sign change. Positive 8 to a negative 11, that's a sign change. So there are 2 sign changes there. Tells me there are going to be 2 negative real zeros, or you might remember there could be none as we count down by 2. So 2 or 0 negative real zeros. So when it comes time to look for our zeros, the first number I'm going to look for is 1, because I know that's going to work. Now, when you plug the 1 in, you should come out with the 0 down here. And that 0 will help you on your factoring. It will leave you with, it will tell you that x minus 1 is a factor. Because 1 was a 0, x minus 1 is a factor. And the cofactor is going to be your quotient. You should find that that quotient is a quadratic, and that quadratic can be factored by normal means. So then you should be on your way to find the other 2 zeros. I'll leave you to finish that. And finally, let's go down here. And when we get down here, we've got 2x cubed minus 5x squared minus 4x plus 12. In this case, we know there's going to be 3 zeros. We have a cubic polynomial, third power, third degree. We take for our rational zeros the factors of 12, which are 1, 2, 3, 4, 6, and 12, and put them all over the factors of 2 of the coefficient 1 and 2. You should come up with a grand total of 16 possible zeros as we put 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, 12 over 1. That'll give us 1, 2, 3, 4, 6, and 12. And then we put each of those over 2. Now some of those will be repeats. We got 1 over 2 is a half. But 2 over 2 is 1. We already have that. 3 over 2 is 3 halves. 4 over 2 is 2. 1 half, and 3 halves, all positive. Is 1 a 0? Is the sum of the coefficients equal to 0? Well, let's see. We've got 2, negative 5, negative 4, and positive 12. 2, negative 5 is negative 3, plus negative 4 is negative 7, negative 7 plus 4 is 5. Tells me no. That 1 is not a 0. Secondly, what about negative 1? So we switch the odd power sign one more time. X cubed is odd, so that 2 becomes a negative 2. X squared is even, so minus 5 stays a minus 5. X to the first is odd, so I'll change that minus 4 to a positive 4. And the plus 12 is even power, so that stays a plus 12. When I add a negative 2, a negative 5, that's negative 7, 4, that's negative 3 plus 12. Unfortunately, that's not 0. So negative 1 is not 0. So out of my list of 16 possible zeros, I'm going to cross positive negative 1. What about the color? See if he tells me anything I can do. I'm going to have positive zeros. We look at these coefficients. We change sign changes. So I got positive to negative here. I've got negative to positive here. So there are 2 sign changes. Tells me for positive zeros, I could have 2 or 0. Okay. What about negative real zeros? So look at these coefficients. Again, sign changes. Looks like I only have 1 sign change from negative 5 to positive 4. Negative 5 to positive 4 is 1 sign change, so I'm going to have 1 negative real zero. So I know I'm going to have as many as 2 positive, maybe none, 1 negative. So I know I've got 1 negative. Keep that in the back of my mind. So now, given all that, I'm going to start looking for zeros of this power value. 2, negative 5, negative 4, and positive 12. As my numbers, what element should we start looking for here? Since I don't know if there's a positive, but I do know there's going to be a negative, I'm going to start on I would start on the negative side. And the first number I would try is negative 2. The easiest one because negative 1 is already out of the game. So I would start with negative 2, plug it in here, and see what you get. Right? I think if you do it properly with negative 2 as your pivot element, what you should find is it's not a 0, but it does produce alternating signs on the bottom. Okay? You will find that the numbers in the bottom row switch from positive to negative to positive to negative. And if you recall from one of our last 2 classes, that alternating signs down here tells you that that is a lower bound, and you don't have to test anything smaller than that. So because a negative 2, try it, show that you get alternating signs, produces these alternating signs. Negative 2 is a lower bound. You don't have to try negative 3, negative 4, negative 6, or negative 12. Okay? They're not going to work. Okay? But we know there's a negative root, so that leaves our fractions. Remember, we had 2 fractions, 1 half and 3 halves, negative 1 half and negative 3 halves. So I would go after those next. I think you'll find that one of those 2 will work, and once you find the one that does work, you'll be left with a quadratic that you should be able to factor easily. Go ahead, see what you can do. And there are some more problems on there with answers posted on Blackboard. Those are strictly for practice. But these are the processes that we're going to be using to find the zeros of polynomials. Hopefully the video lesson was better than whatever videos you might have seen online. We'll see how this goes, and probably try it again just to give you another look at this. Good luck. Hope you all stay well. But that's all for now. Take care of yourself.